Hello everyone. In this video I'm going to discuss the oxidation of alkenes using acidified potassium manganate. This oxidation is done in two ways, um, depending on the conditions used. Either we can use cold dilute acidified potassium manganate, or we can use hot concentrated acidified potassium manganate. Now, each of these oxidation processes give different products. So, for example, if we were to oxidize this alkene that is given on the screen there, it has two double bonds. The first one being this one as the first double bond, and the second one is that one. Now remember, we said that all compounds that have got a double bond are regarded as alkenes. Now, when these are oxidized using an oxidizing agent like potassium manganate here, by definition, in organic chemistry, oxidation is the addition of oxygen to a compound. And if we were to use cold dilute acidified potassium manganate, cold dilute, take note of this, cold and dilute, when such an oxidizing agent has been used, this will give rise, or it will produce, an organic compound that is known as a diol. Right? Let me just write the word diol here. Right? It produces a diol. What does that mean? Diol, the di here is representing 2. So a diol is an alcohol with 2 OH groups. So what happens is, if we use cold dilute acidified potassium manganate to oxidize an alkene, each of the carbon atoms that are involved on the double bond, like we have got this carbon atom and that carbon atom, these are the ones that are involved in the double bond. Now, each of these, if we use cold dilute acidified potassium manganate, each of these will be oxidized, right, by adding an OH to each of the groups, to each of the carbon atoms rather. We add an OH here, and then we add an OH here, and then we break that bond such that we are left with a single bond there. And that is what happens. That is what happens to each of the carbon atoms that will be involved in the double bond whenever an alkene is oxidized using cold dilute acidified manganate. Each of the carbon atoms involved in a double bond will then have an OH, or will be added an OH, and the double bond will break. So this is the product that we will get. As you can see here, each of the carbon atoms that had a double bond, you have been added an OH, right, like that. So if we were to use acidified cold dilute manganate, we would form a compound in which all the carbon atoms that were involved in the double bond will then have an OH group being added to such carbon atoms. Now, the situation is a bit different. If we were to use hot concentrated acidified potassium manganate, like in this case. What happens here is if we use these conditions, hot, concentrated, this will lead to a rupturing or breaking of the double bond. In other words, wherever the double bond was, will be broken into two parts. In other words, the molecule will be broken into parts. For this double bond, we're going to have this part being formed or being broken apart, and we also have going to have this other part being formed. And also here the double bond will break to give two parts, this and that. Now each of the carbon atoms that will be involved in the double bond will also be oxidized, but their oxidation depends on which other atoms does that carbon atom which is involved in the double bond, which other atoms is it bonded to. As you can see, I have written all the carbon atoms that are involved in the double bond using red ink. And our first carbon atom that is involved in the double bond is attached to two other hydrogen atoms, like that. Now, if the other atoms to which the carbon atom which is involved in a double bond are hydrogen atoms, like in the first case. In other words, if that carbon atom is a terminal carbon atom, that is, if it is at the end, then that carbon atom is going to be oxidized to carbon dioxide. So in other words, this part will form carbon dioxide, this one. So always when a carbon atom involved in a double bond is attached to two hydrogen atoms, or if it is at the end, at the terminal carbon, then that carbon will be oxidized to carbon dioxide. So that is the reason why one of the products here is carbon dioxide. It's because this carbon, which was at the end and involved in a double bond, would have been oxidized to carbon dioxide. Now, as I said, oxidizing the alkene using hot concentrated acidified will break the molecule. So we're going to form carbon dioxide when this breaks apart, and the remaining part, the other carbon atom, because this is attached to a hydrogen and the other atom to which it is attached is a carbon. When such a carbon atom is oxidized, it will give first an aldehyde, where we are going to add an oxygen atom here, such that this will be an H. This carbon atom will then be bonded to a hydrogen atom and also doubly bonded to an oxygen atom, and this will give an aldehyde. But because the potassium manganate is a strong oxidizing agent, it will further oxidize the aldehyde, which is going to be formed to a carboxylic acid. So as you can see, on this carbon atom and that carbon atom, we have a similar situation in which both the carbon atoms involved in the double bond are attached to a hydrogen atom and a carbon atom, or an alkyl group, because this is an CH2 group. So whenever a carbon atom that is involved in a double bond is attached to a hydrogen and a carbon or an alkyl group, this will give an aldehyde at first, which is further oxidized to a carboxylic acid. So this end, that carbon will be converted to a carboxyl group, which is a C double bond O, OH. And the same applies here. We're going to have an OH, a C double bond O. And hence the reason why we now have this compound being formed as the other product in that reaction, where we have that carbon, which was in the first double bond from the left, being converted to a carboxyl group, and the other carbon, which is the second, that is now uh, the fourth carbon being converted to a carboxyl group as well. And then the last one, if we have got a situation where the carbon atom which is bonded or which is involved in the double bond being bonded to two carbon atoms or bonded to two alkyl groups, such a carbon atom is converted to a ketone. In other words, we are going to add an O here. So that's the reason why we have got this compound being formed, as you can see there. That's a ketone. So basically, this is what happens when we oxidize alkenes using potassium manganate, acidified potassium manganate. There are two ways of doing that. Either we can use cold dilute acidified potassium manganate, which I've said it gives rise to a compound known as a diol, or we can use hot concentrated acidified potassium manganate that would give rise to different products. Why? Because the double bond will be broken when we use these conditions. When we use these conditions, the double bond is going to be broken, right? And when the double bond breaks, it means also the molecule will be broken into two parts. Wherever the double bond is, when it breaks, it gives rise to two products, right? Because there are two double bonds there. That's the reason why we have got three products being formed. Okay.